find the domain and range of a function 4x cubed plus 3. So when we're trying to find the domain of a formula like this, it's helpful to think about issues that would cause a problem for the function. There are 3 major ones that you want to think about when you're first getting started with this. One of them is division by 0. You can't have division by 0 in math. So if this function was something like f of x equals 1 over x, then x could be any number except 0, because you can't have division by 0. Another problem that occurs is taking the square root of a negative number. The answer to this could only be imaginary. It's not a real answer. So if we had something like f of x equals the square root of x, then x would have to be a number that's greater than or equal to 0. X could not be negative. Also, we can't take a logarithm of a non-positive number. So if we had a function like f of x equals log x, then x would have to be greater than 0. It couldn't be 0 or negative. We can see examples of these 3 situations and where they cause a problem. If we go to Desmos, we can see a graph of 1 over x. So normally, the graph has output values at all different x's. And I said one time in one of my examples that you could even shrink the graph by compressing it vertically with a clever trick of just creating unreasonably large y-axis values. So if I went from negative 1,000 to 1,000, for example, you can flatten the graph down, showing that we have graph at all x's except for where x is 0. So if x is 0, we don't have an answer to that. We can even try 1 divided by 0, and it's undefined. If you assign your function to the label f of x and then do f of 0, you won't get any answer for that. But if you type in any other x, like 1, like 3, like 5, like 1,000 even, or 1,000,000, and you could try negative 1,000,000 too, you'll still get an answer for any x except 0. Now let's look at the problem that occurs with the square root of x. So here's what the square root of x looks like. As we can see, we don't have any graph to the left of 0. That's because inputs that are negative are not allowed. They would be called undefined in the calculator, and so nothing to the left will work. 0 actually does produce an output though, so 0 is part of the domain there. We can use the trick of flattening the graph down by extending the y-axis really large, and we can now see where the domain of this function is. It's everywhere from 0 and it goes to infinity on the right. That's a picture of the domain right there. So the domain of radical x is going to be 0, infinity. The domain of 1 over x is going to be everything from negative infinity to 0, but not including 0, and everything from 0 to infinity. The parentheses indicate that 0 is not included. The union symbol U means that we have to join 2 separate intervals into one domain. Let's also look at the function log x. It has an asymptote at x equals 0. And what it does is it keeps approaching the y-axis. So even though it looks like it might touch the y-axis, if you zoom way in, we could see that it's not quite touching. And so if we try to do f of 0, we'll get undefined. But anything that's positive, even 0.001, would still give us an output. So even if we put a 1 in the 20th decimal place, that still gives us an answer. My point of all this is we want to be able to look at the function formula and determine if any of these three problems is occurring. If none of those problems can be found, then your domain is likely all real numbers. And that would be the case for this formula. It doesn't have division by 0, it doesn't have a square root, and it doesn't have a log. So your domain is all real numbers. That can be written as just big R, or you could write it as the x's that are allowed are between negative infinity and infinity. That's one way to write it. This is called algebraic notation. But there's also interval notation. And so when we write that same thing in interval notation, we have to say the x that we're starting at and the x that we're ending at, and then we put them in parentheses with a comma between them. Here's the graph of 4x cubed plus 3. I can use the Roentgen Desmos to flatten out the graph. So I'll go from something extreme like negative 1,000 to 1,000. We see that it's becoming flatter. And then I'll try negative 10,000 to 10,000. It's becoming even flatter. And let's go even farther. At a certain point, the thing appears to be very flattened out. And we can see that the domain is from all the way on the left to all the way on the right. And so the answer to this one is the domain is from negative infinity to infinity. That's a visual way of looking at the domain, but even if you don't have that visual way of finding it, if you don't have these three problems occurring, the domain is just automatically from negative infinity to infinity. Now this problem also asked for the range of the function. So certain functions are called common functions because they're commonly seen in math problems. And so one of these common functions would be y equals x. All it is just a slanted line that looks like this. Now, with a slanted line like that, we know that it continues forever, both in the right direction and the upward direction. It also continues forever in the left direction and the downward direction. Now, when it comes to y equals x, so you look at the formula for y equals x and think about what is its domain. So this guy has no restriction on what values of x are allowed to be plugged in. He doesn't have division by 0. It doesn't have a square root of a negative, and it doesn't have a log of a non-positive number. None of those problems would occur here. So his domain is automatically by default every possible x, which is from negative infinity to infinity. When it comes to his range, you want to think about what y values will occur. Well, we said here that this thing continues forever in the upward direction. it also continues forever in the downward direction. So his range is going to be any possible y value. And so that's going to be from negative infinity to infinity as well. If we want to see this using a graphical aid, we can do that. Just go to Desmos, type in y equals x. And now I'll use this trick of drastically altering the axes in order to see the x values that are represented here. So change your y values to something really large, like from negative 1,000 to 1,000, or something even bigger. This is the domain of y equals x. It's every x from all the way on the left to all the way on the right. If you want to see the range, then we'll shrink it a different way. For his range, we expand the x-axis. And we're seeing all the y values that are possible here. As we can see, every y is represented by this graph. It's going to continue forever in the upward direction and forever in the downward direction. So that's why his range is any real number. Another graph that's common is y equals x squared. This is a parabola, which looks something like this. So notice that the graph here will continue upward and to the right forever. And he will continue upward and to the left forever as well. So when it comes to his domain, we don't see any problems here. The domain could be any x. There's no division by zero. There's no square root of a negative. There's no log. So there's no restriction on the domain. So one thing about x squared is we're never going to get a negative out of that formula. You could do something like 0 squared, 1 squared, and 2 squared. And these would all be positive. And you could even plug in a negative into that formula as well. But a negative times a negative makes a positive. And so when we look at the types of outputs that we get for x squared, one thing we see is that we're just never going to get a negative out of that. And so, for that reason, the range will not include negatives. So one way to describe the range is we're going to get all y values except negatives. Another way to write that would be that we can get any y that's greater than or equal to 0. To put this into interval notation, it'll be 0, infinity. Here's the graph of y equals x squared. I'll try to flatten it down to the x-axis to see the domain. It's getting flatter. Okay, now it's pretty flat. So we can see the domain is any x value from negative infinity to infinity. Now let's flatten him horizontally. To do that, I'll drastically alter the x-axis. And as we can see, only y values that are 0 or above are possible with this function. Negatives would never occur. Now there are other common functions besides those two. We have y equals x cubed, y equals x to the fourth, and so on. These are all considered common functions that we encounter commonly. Let's take a look at what they look like. Here's y equals x. Here's y equals x squared. Here's y equals x cubed. Y equals x and y equals x cubed have certain things in common. They both will extend to the right forever and to the left forever. There's no restriction on the x values that you can plug into x cubed. So both of them have the same domain. The domain is negative infinity to infinity. When it comes to their ranges, they both extend upward forever and downward forever. And so they have the same range. And this would be true for any transformation of these functions, such as if we were to multiply them by 4, they would still follow this same pattern. You could even invert them with a negative, but their domain and range is still going to be the same. You could shift them by adding a constant, but this phenomenon of them continuing forever, both to the left and right and up and down, is not going to change. So when it comes to finding the range of 4x cubed plus 3, he's just a transformation of the common function x cubed. And so his range is going to also be all real numbers. So we could write that as we can get all y values between negative infinity and infinity. Or we could just write it in interval notation that the y's are going to be between negative infinity and infinity. It turns out that y equals x to the power of 4 is actually more similar to the function x squared. They share the same basic properties, that they're going to extend forever to the right and left, and they both extend forever upward, but with both of them we don't get any negatives. And so there's going to be a pattern here where x's with an odd power will be similar to each other. And x's with even powers are going to be similar to each other as well. Keep in mind that all of these functions have the same domain, which is just negative infinity to infinity. But odd functions have a range that's different from even functions. Odd functions will have a range of negative infinity to infinity. But when we're talking about even functions, they can't have negatives as outputs. So their ranges will be from 0 to infinity.